In this problem, we have to find a schedule for a list of courses. So you are given n number of courses. Some of the courses are very basic, which do not require any prerequisite knowledge. Some courses are more advanced and they require some courses to be completed before you can take those courses. So here we have to return a proper ordering, a proper list, such that if we follow that list starting from beginning, we should be able to complete all the courses. And if such ordering does not exist, we will return an empty list. If there is some cyclic dependency, like course A is dependent on B, B is dependent on C, but C is in turn dependent on A. In this case, we can never do these three courses. So let's take an example. So here we will give an input in some format and it's a list of edges. So you can straight away think of it as a graph problem. And this ordering is important. AB is not same as BA. If you take it differently, your answer will be just reverse of the expected answer. So AB means first you have to take B, then A. So you have to take in mind the ordering is slightly opposite here. So first take B, then take A. So this is one such possibility, and you will also be given how many courses are there. So number of nodes you are given and all the edge lists are given. So let's draw the graph. So 1 0 means you can take 0 first, then only you can take 1. So this arrow will denote I will first take this, then go to this. So this is 0 is the prereq. If you don't do 0, you cannot complete 1. Similarly, 2 is dependent on 0. So read it like this, 2 is dependent on 0. So you take 0 and then you can take 2. Then 3 is dependent on 1. So from 1 you can take 3. And 3 is also dependent on 2. So 3 is dependent on 2 courses, 1 and 2. So in order to complete that, first you complete 1 and 2. So what is the problem here? So just pause for a minute, think of the solution that you can come up with. It should not be very difficult. And once you have the solution, come back to it. So clearly we have to do topological sort. But there is one more thing that you need to take care. It will not be just plain topological sort, but in this case, there may be a cycle that's given. That's one of the possibilities. If the ordering is not possible, return empty list. And when the ordering will not be possible, when we have a cycle. For example, 0 is dependent on 1, 1 is dependent on 2, and 2 is dependent on 0. So in this case, it's not possible to complete these courses. So we have to mix two things in our solution. One, we have to do a topological sort. So we will construct our adjacency list from this. So it will look like 0 has 1 and 2, 1 has 3, 2 has 3, and 3 does not have any outgoing neighbor. This is the adjacency list. Once we construct this, we will do topological sort. And in that only, we will insert the logic for cycle detection. So I would recommend to study topological sort and also cycle detection in directed graph. Although we will code both of these here, we will need both of these combined in one DFS call, and we can detect that. So what will be the topological sort here? So we will have a stack, and we can start from any node. Let's say we start from 0 and we go to 1. From 1 we go to 3. From 3 there is nowhere to go, so we are done with this. So we put 3 in the stack and we come back to 1 since we came from 1. And now there is no way to go from 1 also. So all the options are exhausted. So we put 1 into the stack and come back to 0. From 0 there is one more path which we have not explored. So we come back to 2. From 2 we can only go to 3, which is already visited. So we are done with 2 also and we go back to 0. But before going back, insert it into the stack. And then from 0 there is no other option. So finally we are done with 0 and we insert 0 here. And we may have some more vertices like this. In that case, we will trigger another DFS call. Since we have two connected components here, from 4 you cannot reach all of these. Similarly, from any of these you cannot reach 4. So that is possible. So accordingly the stack will be adjusted. Now we will pop one element at a time. So 0 is popped, then 2 is popped, then 1 and 3. So this ordering is valid. You can see We can do 0 first. Yes, it's not dependent on anything. There is no incoming edge. Then we can do 2. Only one incoming edge is there, which is 0. And 0 we have already done. So we can do course 2. And now course 1 also we can do, since course 1 is dependent on 0, which we have already finished. And then we can do 3, since 3 is dependent on 1 and 2, which we have already done. So this is a valid ordering. But in this case, it will not be possible. There is a cycle. So let's write the code for this. And we will do it in all 3 languages. You can go through this example. This is in fact the similar example which I had taken. So we will define our adjacency list, which will be vector of vector of int, and its size is fixed. We know the number of courses beforehand. And let's build this. So what we will do, vector of int. So we will iterate through this list of edges, prerequisites, and what we have to push adj. 10 means like here you have 1 means 0 is dependent on 1. So there will be an arrow from 1 to 0. So the second component to first component. So first will be the neighbor of second. So that you have to write carefully, otherwise your answer will be wrong. So adj courses 1 dot pushback so each of these has 2 elements in it. These 2 elements. In the second one, adjacency list of second one, push the first one, and that is what we are doing here. So adjacency list is built for us. Now our only task is to implement the DFS. So let's implement it here. But additionally, we have to also check cycle detection, and we have seen how to detect cycle in a directed graph using DFS in our earlier lesson. So we will write the same thing. Let's name it DFS, or you can have cycle present or something like that also. Has cycle int u. Then we will have a vector of int, which is the adjacency list, and then we will have visited. We will put it first. Let's define our stack. Since we have to return vector of int, we can take a vector instead of a stack. In normal implementation we will use stack, but we can always append in the end of vector, and that will, and while popping we can pop from the end, so that can act as a stack also. So I'm using this since we have to reverse it in the end. So we pop an element from the stack and print it and so on. We can also keep inserting in the beginning, but inserting in the beginning is costly. Every time it will shift. So what we will do, we will just insert in the end, and finally we will reverse everything in just one line. So that is the intent. You can also take a stack here and then pop one at a time and then build your result. I will call it S to denote that it's a stack. And while detecting cycle, it was slightly different from normal DFS in that in normal DFS we just keep track of visited or unvisited, and in the case of cycle detection we keep track of 3 states. One is that it's unvisited node. Second is that we have reached there and we are exploring the paths from there, but we are not done with all the paths. So that's in the stack. We have reached there, it's not unvisited, we have reached, but we are not done with that. So there are 3 states, and once we are done with it, that is the third state. So we have a vector of int instead of bool. It can have 3 states. Initially all are in 0 state, that is unvisited. and make sure to pass all of these by reference. And finally we pass visited. So we will return true when there is a cycle, otherwise we will return false. So if ith node was unvisited and we started DFS from there and it returned true, that is there was cycle, then we will return empty vector, no such ordering exists. And finally we will reverse this vector s dot begin, s dot end. And now let's complete this DFS function. So first and foremost we will set visited of u equal to 1. So earlier it was 0. 1 means we have reached there and we are exploring the paths from there, but we have not done with DFS from there. So we are looking at its neighbors. If visited v is equal to 1, that means it's also in the stack. So we found a cycle here, it's a back edge. So return true, no need to proceed further. We found a cycle, we return. If cycle is not present and visited v is 0, if some node is completely visited and we are done with that, that state will be 2. We will not go there again. But if it's unvisited, we can trigger another DFS. The same thing. And finally we set visited u equal to 2 and then s dot pushback. Return false means we did not find any cycle, and this stack will now hold the elements in topologically sorted order in reverse way. And let's run it. And this works. Let's test on the second example. And this is as expected. Let's take a cycle, 2 courses, 0 1 and 1 0. And it gives empty list as expected. Now we will write the same thing in Java and Python. And here we will have a list of integer array. And this is the stack, and visited will also be an int array. So this DFS part is implemented. Now we will look at this. And its number of courses. And this is an array of lists. and we have to also initialize all of these lists. And then so adjacency list is built now. What else? This is list of integers. So this reverses the list, but it's a list of integer and not int, and we can convert it to array using toArray, but that will create array of integer and not int. So what we will do, we will have, you can also keep pop one at a time and put it into this result, or you can do it in one line. s.stream. And finally return the result. And Java solution is also accepted. Finally, we will write it in Python. We will put everything which we are passing by reference into self so that we can refer it here. Empty list for I in range num courses, and then adjacency list is built. Then this is the list which will act as stack. and the answer matches with expected. So let's submit, and the Python solution is also accepted.